Hello, this is Lazarus at telecomTech, where telecom and networking technologies are simply explained. Today we'll be simply explaining virtual LANs, or VLANs. We've already talked about why it's important to limit the size of broadcast domains and to properly segment a network into layer 2 segments. Here we have a layer 2 network which is completely flat. We have layer 2 switches everywhere and a whole series of devices that are connected to them. This is one big broadcast domain. Now, this is a design that should be avoided. We need to segment this network into smaller broadcast domains where each broadcast domain will correspond to a specific IP addressing subnet. If we try to achieve this segmentation by using only physical hardware, we could do it by replacing some of the switches with routers, as you see here, allowing each network segment to be defined by a single switch connected to a router. Remember, the router acts as the boundary of every broadcast domain and as the default gateway for that subnet. In such a model, each individual switch or group of interconnected switches would represent a single network segment, and every router interface would connect to exactly one broadcast domain. Now, this would result in network segments that can correspond to particular sections of a network, such as departments of a business or any other method of segmentation that you desire. However, the problem is that this kind of design quickly becomes cumbersome and expensive. Any changes to your network segmentation could mean rearranging hardware, buying new devices, and physically recabling parts of the network. Now, VLANs have been introduced to address this very issue. Now, VLANs allow us to logically divide a switch into multiple broadcast domains by assigning specific switch ports to specific VLANs. By doing that, we can make those ports behave as if they belong to separate layer 2 switches. For example, on a single 24-port switch, some ports could belong to VLAN 10, others to VLAN 20, and others to VLAN 30. Even though they all exist on the same physical switch, each VLAN forms its own virtual layer 2 segment, its own broadcast domain. Now here we have to make a distinction about terminology. We often refer to a managed switch and an unmanaged switch. This here is an unmanaged switch. This here is a managed switch. You can't really tell the difference from the outside, but this is what they really are. They both come in various sizes and with various port numbers, but the difference is internal. An unmanaged switch is one that has no command line interface and cannot be configured, so its behavior is not modifiable. It still has a MAC address table and provides switching functions, but no parameters can be changed. An unmanaged switch will have the same VLAN on all ports, and it will always work like this. Now, a managed switch is one that has an interface from which you can configure parameters on it, either a web interface or a command line interface. And through that interface, you can configure VLANs on particular ports. Now, VLANs can only be configured on managed switches, not on unmanaged switches. Now, how do VLANs work? Well, by default, a managed switch will have all its ports set to VLAN 1. VLAN 1 is known as the default VLAN. So a managed switch, right out of the box, behaves like an unmanaged switch. Now you can go into the command line interface, create new VLANs within the switch, and then assign them to each port. You can assign them however you like. VLAN 10 on these ports here, for example, VLAN 20 on these ones here, and VLAN 30 on these ones. The configuration commands to assign VLANs are stored in the running configuration, and that information is then used by a couple of other entities within the switch to make the functioning of VLANs work. Now, the first of these entities is the MAC address table. Now, we've already looked at this in a previous video in detail. What we see is that in the MAC address table, we see an entry for the VLAN to which a particular port belongs, as well as the MAC address that is connected to that port. This information is important to ensure that inter-VLAN communication does not take place directly. Any frame that comes into a switch port, like this one for example, if it's a broadcast frame or if the destination MAC is not yet in the MAC address table, it won't be flooded out of all ports of the switch, but it'll only be flooded out of the ports of the switch that belong to the VLAN of the incoming port. Thus, any broadcast frames will only reach ports of the same VLAN. And this is achieved using the information that is found within the MAC address table. Now, the other entity involved in this process is the VLAN database. Now, this is a separate entity in memory that cannot typically be manipulated directly. It's a repository where VLAN information is maintained based on the configuration of each individual interface. The VLAN database exists to maintain a persistent record of which VLANs are defined on a switch, including their IDs and other basic attributes. It allows the switch to consistently enforce layer 2 segmentation, and in Cisco networks in particular, it also supports features like VTP for VLAN distribution and synchronization between multiple switches, which we'll talk about in a future video. Now, as we mentioned in previous videos, VLANs typically align with IP subnet addressing. Now, to see this in action, let's take a look at this switch setup again. This time I've added the IP addresses of the hosts. Here we see that we have several departments in a small office, and we have separated them with different VLANs and different IP subnets. We have a default gateway, which is this router here, that serves the subnet of each VLAN. Now, this setup allows inter-VLAN communication via the router, which will route between subnets. Now, this setup is conceptually the same thing as this. Now, you can immediately see how much more cumbersome this design is and more expensive as well, and how unforgiving it is if you want to move a host from one subnet to another. Here you have to connect the device to a different switch, while in the previous situation, it was as simple as just configuring the port. You just change the VLAN to which the port is assigned and assign the host the appropriate IP address in the correct subnet, and you're done. So you can see the difference between using physical infrastructure to segment a network and using VLANs to segment a network. The VLANs obviously are much more flexible, elegant, and much more preferable. Now, before I end off, I'd like to give you a preview of a couple of important associated concepts. We saw how communication takes place between two hosts in different VLANs using an external router. Well, this can also be achieved using inter-VLAN routing on the switch itself. A layer 3 switch has routing capabilities and can route traffic between VLANs internally. Now, another important concept is that of a trunk. What if you have two switches connected to each other like this? You will want the Sales 1 host here to have layer 2 communication with the Sales 3 host here. They'll be on the same subnet. And the IT1 host to have layer 2 communication with the IT3 host here. But you only have a single link between the switches. To what VLAN will you assign these ports here so this whole thing will work? Well, you can configure this link as a trunk, which allows the traversal of frames from multiple VLANs over that same link. Now, we'll talk about both of these concepts in upcoming videos. For now, thank you for staying with me until the end of the video. If you're still here, you're probably serious about learning networking, and that's exactly why I make these videos. If you want to continue learning in a more structured way, check out my website at telecomTech.io. There, I'm building full courses with labs, quizzes, and real-world examples designed to help you truly master networking technologies. Join the newsletter while you're there so you don't miss any new content. I'm Lazarus at telecomTech. I hope this has been helpful for you, and I'd like to thank you for watching.